Last time we started power series. Power series looks like n equals 0 to infinity Cn x to the n power. So it can be expanded like C0 plus C1 x plus C2 x squared and so on. Other one is summation Cn x minus a to the n power. So it can be expanded like C0 plus C1 x minus a plus C2 x minus a squared and so on. This is called the power series about A or centered at A. So we were doing the examples last time. Let's do one more example. Let's say the given power series is defined as summation n equals 0 to infinity minus 1 to the n power times x to the 2n power over 2 to the 2n power times n factorial squared. This function is called Bessel's function. What we wanted to do was we wanted to know where the power series converges because x is an unknown number. So in this case, because of n factorial, we cannot use the root test. So we will use the ratio test. Ratio test goes like limit a n goes to infinity, a n plus 1 over a n. And that equals limit n goes to infinity, a n plus 1 times 1 over a n. So that becomes, we plug in n plus 1 to n. So minus 1 to the n plus 1 times x to the 2 times n plus 1 power over 2 to the 2 n plus 1 power times n plus 1 factorial squared. And then we have 1 over n. So we flip this. Then we have 2 to the 2n power times n factorial squared over minus 1 to the n power x to the 2n power. We are thinking about the absolute value, and so we can ignore the negative 1 to the something power. And we want to gather similar things together. So these will be combined. For this one, we can rewrite that as x 2n power times x squared, right? And x to the 2n times, we will combine this one with this one. So 2 to the 2n on the numerator, and the denominator is 2 to the 2n plus 2. So this one and this one will be combined. So n factorial squared over n plus 1 factorial squared. So For this one, this can be written as 2 to 2n power times 2. And for this one, we can rewrite that as n plus 1 times n, just n plus 1 times n minus 1, 2 times 1. And so this part can be written as n factorial. So that can be written as n plus 1 times n factorial. And we square that. So this can be rewritten as n plus 1 squared times n factorial squared. So let's simplify for this part. So we simplify by canceling d out. And for this part, we cancel d2 out. And for the last part, we cancel this and this one. And so what we are getting is absolute, so I have to put limit absolute value of x squared over 2 squared times, for these two cancel each other, and so n plus 1 squared right. And then we are sending n goes to infinity. So this is a fixed number, this increases, and this is a random number, but still fixed number, unknown fixed number. And when we think about the limit will go to 0. And so this ratio's limit is 0, which is less than 1 for all x, right? And so what we can say is by the ratio test, the series converges for all values of x, because that is independent of x. So this is the domain of the Bessel's function, because the function is defined in this way, and this series converges means the function value is defined, and that is defined for any value of x. The next statement is for a power series, summation n equals 0 to infinity Cn x minus a to the n power. There are only 3 possibilities. The series converges only when x value equals a. So basically, it makes everything 0 other than the zeroth term. The second case is the series converges for all x. The third case is there is a positive real number such that the series converges. If absolute value of x minus a is less than r and diverges if absolute value of x minus a is strictly greater than r. So in this case, there is a special name about this r. R is called radius of convergence. In this case, the first case, when the series converges only when x equals a, the radius of convergence is 0. And in the second case, the series converges for all x. So we can say that R is infinity. There is a notion of interval of convergence. Interval of convergence is further clarification of this inequality. So in this case, the series converges between when the absolute value is less than absolute value of x minus a is less than r. So that can be rewritten as x minus a is between negative r and r. However, in these boundary points, the series may converge or diverges. So interval of convergence clarifies whether the series converges or diverges at the boundary point. So interval of convergence is all values of x. For which the series converges. So in this case, if we have a specific interval, and then there are 4 cases, those are open parenthesis a minus r and a plus r. So this one, parenthesis means not including a minus r and a plus r are not included. The bracket notation means the boundary point is included. And so the series converges at a minus r, and it converges all the way through a plus r, but we are using parentheses here, and then the series diverges at a plus r. And the opposite case can happen. So open parenthesis, a minus r, a plus r, and close bracket, and the interval of convergence can include a plus r and a plus r, both boundaries. Okay. Find the radius of convergence. And the interval of convergence. So the first example is a zero summation n equals 0 to infinity, -3 to the n power times x to the n power over square root of n plus 1. We cannot use the root test even though we have n power because of the denominator. So we will use ratio test. Limit n goes to infinity, an plus 1 over an. So that equals an plus 1 times 1 over an. So that is limit n goes to infinity. Absolute value of an plus 1 is -3 to the n plus 1 power times x to the n plus 1 power over square root of n plus 1 plus 1. So we are substituting. And then we flip it. Then we have square root of n plus 1, and denominator will be -3 to the n power times x to the n power. We are working within the absolute value, so we can forget minus sign here. So let's gather all the similar things together. Limit n goes to infinity. I will combine this one with this one. So we have 3 to the n plus 1 power over 3 to the n power. So this one over this one. So we have x to the n plus 1 power over x to the n power. And then we have this one. So square root of n plus 1 power, n plus 1, and square root of n plus 2, 1 plus 1. So that is limit n goes to infinity. N plus 1 minus n will make 3, right? 3 to the 1 power. 3 times this one is x. And we notice that this will go to 1. So that is 3 times absolute value of 3 times x. So by the ratio test, The series converges. Absolutely. If absolute value of 3x is less than 1, so we divide by 3 on both sides, then we get absolute value of x is less than 1 over 3. So therefore, we can think about the interval between negative 1 over 3 to 1 over 3. And we can say the series diverges if absolute value of 3x is greater than 1. So if we divide by 3 on both sides, then we get absolute value of x is greater than 1 over 3. From college algebra, you learned this means x is greater than or greater than 1 over 3, or x is less than negative 1 over 3. So in the problem, what you have to know is about radius of convergence and the interval of convergence. Radius of convergence is this number. So this is radius of convergence. To determine whether what the interval of convergence is, we have to check at the boundary point. That means we will put x equals negative 1/3 or x equals 1/3, and then check whether the series converges. The first case is if x is negative 1 over 3, then summation n equals 0 to infinity, negative 3 to the n power times negative 1/3 to the n power over square root of n plus 1. So x equals 1/3. So the given series is negative 3 to the n power. X was negative 1/3, and so we did substitution here. So that equals, what is that? Summation n equals 0 to infinity. Those are the same power, so we can combine those. So negative 3 times negative 1 over 3 to the n power over square root of n plus 1. So those will cancel each other. So we think about summation n equals 0 to infinity 1 over square root of n plus 1. So if you expand this out, then it starts with 1 over square root of 1 plus 1 over square root of 2 plus 1 over square root of 3, and so on. And so this can be regarded as a P series with P equals 1 over 2. The power is 1 over 2. So that diverges because that is strictly less than or equal to 1. The second one is if x equals 1/3, then instead of negative 1/3, we will think about 1/3 here. So then summation n equals to 0 to infinity, negative 3 to the n power times 1/3 to the n power over square root of n plus 1. So we do the same thing. So we have summation n equals 0 to infinity. We combine those together because the power are the same. So negative 3 times 1/3 to the n power over square root of n plus 1. So that is summation n equals 0 to infinity, negative 1 to the n power over square root of n plus 1. So we have alternating series. With Bn equals 1 over square root of n. So obviously, Bn is a decreasing sequence because Bn is 1 over square root of n, and Bn plus 1 equals 1 over square root of n plus 1. And then obviously, Bn is greater than or equal to Bn plus 1. And another condition is limit n goes to infinity. Bn is limit n goes to infinity 1 over square root of n that equals 0. So by the alternating series test, the series converges. At the boundary, what we have shown was when x is negative 1/3, the series diverges, while when x is 1/3, the series converges. So the interval of convergence will be open parenthesis negative 1/3 and 1/3 close parenthesis, the bracket. So any questions so far? No? Let's do the next example. The next example is summation n equals 1 to infinity 9x minus 8 to the n power over n times 9 to the n power. So the sequence an equals 9x minus 8 to the n power over n times 9 to the n power. So again, because of the multiplication by n, we cannot use the root test. So we will continue to use the ratio test. Limit n goes to infinity, an plus 1 over an. So that equals limit n goes to infinity, an plus 1 times 1 over an. And then limit n goes to infinity, we just do substitution. Substitute n plus 1 for n. So 9x minus 8 to the n plus 1 power over n plus 1 times 9 to the n plus 1 power times, we flip it, then we have n times 9 to the n power over 9x minus 8 to the n power. Okay, I will check it after the class, okay? So let's do this. So this one, 9x minus 8 to the n plus 1 power over 9x minus 8 to the n power, and we will combine these two. Then we have n over n plus 1 times 9 to the n power over 9 to the n plus 1 power. So we can say that limit n goes to infinity. So it has one more power. So we have 9x minus 8 times n over n plus 1 times this one. The denominator has one more degree, and so 1 over 9. And when we think about the limit, x is just an unknown fixed number, and so these two are fixed number. And for this part, n over n plus 1, that'll go to, so actually that'll go to 1, right? So limit will be 9x minus 8 over 9. So what you can say is by the ratio test, the series converges when absolute value of 9x minus 8 over 9 is less than 1. So we multiply by 9 on both sides, then those will cancel each other, and we get absolute value of 9x minus 8 is less than 9. So we can rewrite this absolute value involved inequality by writing it as negative 9 to 9. And then we add 8 on each side. Then left side will have negative 1. And in the middle, we have 9x. And on the right side, that is 17. So x is between negative 1 over 9 and 17 over 9 on the right side. So what can we say about the radius of convergence? Radius of convergence is determined by this inequality, and this is the radius of convergence. And so radius of convergence is 1. And we got this interval. To get the interval of convergence, we have to check at x equals -1/9 and x equals 19/7. So if x equals -1/9, then we go back to this one and we plug in 1/9 here. And we get an equals 9 times -1/9 minus 8 to the n power over n times 9 to the n power. So these will cancel each other, and we have -1 minus 8 to the n power over n times 9 to the n power. Therefore, we have -9 to the n power over n times 9 to the n power. So we can further simplify by writing this one as -1 times 9. So -1 to the n power, 9 to the n power over n times 9 to the n power. So those will cancel each other. So we have -1 to the n power over n. So what we know is summation n equals 1 to infinity, -1 to the n power over n is an alternating harmonic series. So therefore, the series converges. Okay. And then we have to think about this point. So again, we will replace x by 17/9 in an, the given sequence. So if x equals 17/9, then an equals 9 times 17/9 minus 8 to the n power over n times 9 to the n power. So these two will cancel each other, and then 17 minus 8 to the n power over n times 9 to the n power. So this one will be 9 to the n power over n times 9 to the n power. And those two will cancel each other. So we have 1 over n. So we know that n equals 1 to infinity, 1 over n is a harmonic series. So it diverges. So interval of convergence will be we know that this converges and this diverges. So open bracket -1/9 to 17/9 with close parenthesis, close with parenthesis. So any question?